So here we're going to work on some examples that when we use direct substitution initially, we get an indeterminate form 0 over 0. So here we're looking for the limit as x approaches 5 of this function here. And we can see that when we substitute a 5 indirectly, 5 squared minus 2 times 5 minus 15 gives us a 0, and of course the 5 minus 5 gives us a 0. So we get indeterminate form here, and we have to decide which technique to use that's going to help us find an answer. In this case, we can see this trinomial, this quadratic trinomial, and a linear denominator. So that's a good kind of clue that really what we want to do is cancel out this factor. So in order to do that, we're going to have to factor the numerator. So we factor that numerator out. X squared minus 2x minus 15 factors into x minus 5, x minus 5. We can then cancel out the x minus 5 terms, and all that's left is x plus 3. So when we do that, now we can use direct substitution. Substitute the 5 in for x. 5 plus 3 is 8. So this original limit is equal to 8. Another example here. We have the square root of the quantity 3 plus x minus the square root of 3 all over x, and we want the limit of that function as x approaches 0. Again, when we use direct substitution, plug a 0 in there, we get root 3 minus root 3 gives us 0. Plug a 0 in for x, or we substitute a 0 in for x, we get 0 over 0. So there's the indeterminate form again. In this case, what we're going to do is multiply by the conjugate. So remember, the conjugate is the same two terms, but the opposite sign. So we're going to use the square root of 3 plus x and the square root of 3, but when we multiply, the conjugate is a plus square root of 3 here. So we're going to multiply both numerator and denominator by conjugates. And again, when you FOIL out this numerator times the numerator of this equivalent of 1, the end result is going to be 3 plus x minus 3. I'm going to multiply this x by this quantity here, and I'm not even going to distribute it, I'm just going to leave it in that form. Because what happens here is, obviously 3 minus 3, those cancel out. Now I have an x in the numerator and an x factor in the denominator, which cancel, and I'm just left with a 1 in the numerator. So what I've done now is I've canceled out that numerator. I have a 1 in the numerator, and what's left in the denominator is just this part in parentheses here. I still want the limit as x approaches 0, so I use direct substitution again. I substitute the 0 in here. I get 1 over root 3 plus root 3. I can write this as 1 over 2 root 3, or if you want to rationalize that denominator, you can make it root 3 over 6. But in our course, we don't have to, I don't really care if you rationalize the denominator, so we can just leave it in that form if you prefer. Our last example for this lesson here is example 3, and you can see that this is a complex fraction. I have 2 over x minus 1 plus 2 all over x. And again, always my first step, even when they look complicated like this, is to try direct substitution. When I do that, I get 2 over negative 1, which is negative 2 plus 2 is 0. And of course, when I substitute that x in for the denominator, I get a 0. So I do get indeterminate form for that. So in this case, what I'm going to do is multiply through by the LCD. So when we're talking about the lowest common denominator, what I'm looking at is any complex portion in the numerator and any complex portion in the denominator, and the lowest common denominator of those denominators. So in this case, there's no complex part in the denominator of our function, so it's just the x minus 1. So I'm just multiplying here. The LCD is just x minus 1. So I'm multiplying the numerator and denominator by x minus 1. What happens here is I multiply the x minus 1, I distribute it to this first part of the numerator. And when I do that, the x minus 1's cancel, and I'm just left with the 2. And when I distribute this x minus 1 to this part of the numerator, which is just the 2, I have 2 times x minus 1. So that's where that part of the numerator comes from. When I multiply the denominators, I have x times x minus 1. Again, I'm not going to distribute that x, and we'll see why in the next step here. I just leave it as x times the quantity x minus 1. And now if I were to distribute this 2, you'll see I get 2x minus 2. So I have 2 plus 2x minus 2. The 2 minus 2, they cancel out. I'm just left with 2x. Now I have in my denominator x times the quantity x minus 1 and 2x in the numerator. Those factors of x will cancel out. I'm left with 2 over x minus 1. And again, I try direct substitution. X equals 0, so I have 2 in the numerator. 0 minus 1 is negative 1. Negative 2 is my limit.